We have done integration of ax to the power of n. Now we are going to have a look at integration by substitution. Normally, when we use integration by substitution, when the expression is hard to expand. And we also use integration of substitution when we deal with integration of trigonometric, exponential, or log functions. So when we have condition where the expression is hard to expand, or we deal with trigonometric, exponential, log, or log functions, we use integration by substitution. The basic idea of integration by substitution, let's have a look. For example, we want to integrate 2x minus 4 to the power of 6 with respect to x. Before this, we know that for integration, we don't have any product rule, quotient rule. So this rule doesn't apply for integration. The only way we do it is either you expand, then you integrate, or you do integration by substitution. The technique to do integration by substitution, let's look at this example. First, let u equals to 2x minus 4. So we will have du over dx equals to 2. Du equals to 2 dx. dx is equals to du over 2. Hence, dx is equals to 1 over 2 du. Use this to substitute into this, and also the value of 2x minus 4 equals to u to substitute into the bracket there. Hence, we have integration of 3, since this one we substitute with u, to the power of 6. dx we substitute with 1 over 2 du. Therefore, we will have integration of 3 times with 1 over 2 becomes 3 over 2 u to the power of 6 du. Properties of integration, you can bring constant out. So which means that it becomes 3 over 2 times with integration of u to the power of 6 du. Now we have u to the power of 6. We integrate like usual. U to the power of 6 plus 1 over 6 plus 1 plus c. And then simplify everything. 3 over 2 times u to the power of 7 over 7 plus c. 7 times with 2 becomes 14. So the final answer is 3 u to the power of 7 over 14 plus c. Don't forget to change u, so it becomes 3. So u is just equals to 2x minus 4 to the power of 7 over 14 plus c. This should be your final answer. How about if we try a slightly harder example? Suppose we have integration of 2 over 3 4 minus 5x to the power of 3 with respect to s. So we want to integrate this. First, rearrange everything. It will become integration of 2 over 3 times with 4 minus 5x to the power of negative 3 with respect to x. And again, constant we can bring outside, becomes 2 over 3 times with integration of 4 minus 5x to the power of negative 3 with respect to x. Here we let u equals to 4 minus 5x. Therefore, du over dx is equals to negative 5. Du is equals to negative 5 times dx. Dx is equals to negative du over negative 5. Hence, dx is equals to negative 1 over 5 du. Now use this value, substitute into here, and use this one, substitute here. So we will have 2 over 3 times with integration of u to the power of negative 3 times with dx is negative 1 over 5 du. So again, this is a constant. When we have a constant, we can bring outside, becomes 2 over 3 multiply with negative 1 over 5, integrate with u to the power of negative 3 with respect to u, becomes negative 2 over 15, integration of u to the power of negative 3 du. Now we integrate as usual. U become u to the power of negative 3 plus 1 over negative 3 plus 1 plus with c. So becomes negative 2 over 15 times with u to the power of negative 2 over negative 2 plus c, becomes, you can simplify that, 0, negative divided by negative becomes positive. So we have 1 over 15 u to the power of negative 2 plus with c equals to 1 over 15 u to the power of 2 plus with c. Substitute u back, becomes, because u is just equals to 4 minus 5x, so it becomes 1 over 15 times with 4 minus 5x to the power of 2 plus c. So that is your final answer. Now we are going to have a look at on how to apply integration by substitution involving trigonometric, exponential and log functions. Before we start, let's go back to the basic of differentiation. We know that when we differentiate sine x, we will get cos x. When we differentiate cos x, we will get negative sine x. When we differentiate tan x, we will get sec square x. And if we differentiate e to the power of x, we will get e to the power of x. And if we differentiate ln x, we will get 1 over x. which means that if we integrate cos x with respect to x, we will get sin x plus with c. If we integrate sin x with respect to x, negative sin x with respect to x, we will get cos x plus c. Therefore means that integration of sin x with respect to x will get negative cos x plus c. If we integrate sec squared x with respect to x, we will get tan x plus c. And if we integrate e to the power of x with respect to x, instead we will get e to the power of x plus c. And the last one, if we integrate 1 over x with respect to x, we will get ln x plus c. These are the important formulas that you need to remember somehow. Now let's have a look on how to apply this into the question. Example, we need to integrate cos 6x with respect to x. We let u equals to 6x, so therefore we have du over dx equals to 6, du equals to 6 dx, and dx is equals to 1 over 6 du. Substitute this into the equation. We will have integration of cos u dx becomes 1 over 6 du, so times with 1 over 6 du. Again, constant can bring outside, becomes 1 over 6 times with integration of cos u du. And from previously, we know that integration of cos x, we will get sin x, means that integration of cos u, we will get sin u. So sin u, and don't forget to plus c at the back. Final answer is sin u over 6 plus c. Substitute back u, becomes sin 6x over 6 plus c. Let us try doing one more example. Integration of 2 cos y minus 6x with respect to x. And we know that by the formula, integration of cos x is just equals to, with respect to x, it's just equals to sin x plus c. That is the basic formula that you need to remember. So here, again, 2 is constant, so we can bring 2 outside, becomes 2 times with integration of cos 1 minus 6x with respect to x. So let u equals to 1 minus 6x, du over dx is equals to negative 6, du is equals to negative 6 dx. Therefore dx is just equals to negative 1 over 6 du. Then you can substitute into this equation here. So becomes 2 times with integration of cos u multiply with value of dx, which is 1 over 6, sorry, negative 1 over 6 times du. Since negative 1 over 6 is a constant, bring it outside, becomes 2 times with negative 1 over 6 times with the integration of cos u du, which is equals to negative 2 over 6 multiply with sine u plus with c. Therefore, simplify everything, becomes 1 over 3 multiply with sine, again u is just equals to 1 minus 6x, and at the end just add plus c. Okay, let's have a look at one more example. So from the formula that we learned before, integration of sine x dx will produce negative cos x plus c. So this is the formula that we are going to have a look. So first step here, just let u equals to 1 over 2x minus 5. And we have du over dx is equals to, just differentiate this, we will get 1 over 2. Cross multiple, we bring the x here, 2 we bring to the left hand side, so it becomes du equals to 2 du is equals to dx. Then we substitute into the original function, so integration of sine u multiply with dx is just equals to 2 du. And we know that when we have a constant, we can bring outside, it becomes 2 times with integration of sine u with respect to u, which is just equals to 2 from the basic formula times with negative cos u, and do remember to plus c. So the answer is negative 2 cos u plus c. Insert the original value of u, which is 1 over 2x minus 5. So my final answer is negative 2 cos 1 over 2x minus 5 plus with c. Okay, the next example will involve exponential function. Again, basic formula, integration of e to the power of x with respect to x is just equals to e to the power of x. Therefore, in this case, we let u equals to 1 over 2x plus 2 du over dx is just equals to 1 over 2 du is just equals to dx. Substitute into the original integration formula, integration function. So we have negative integration of e to the power of u, this is your u, and dx is just equals to 2 du. And again, constant can be bring outside, so becomes 2 times with integration of e to the power of u du. Integration from the basic formula, we will get 2 e to the power of u plus with c, because the integration of e to the power of u is just e to the power of u. Then substitute back the value of u, we should get 2 e to the power of 1 over 2x plus 2 plus with c. So that's the end of the integration by substitution. The next thing we are going to have a look on finding equation of the curve from its gradient function. Finding equation of the curve from its gradient function means that we want to find y from gradient function is dy over dx. If we are given dy over dx, means that if we want to find y, we need to integrate dy over dx. To find equation of the curve, need to integrate the gradient function. Now let's have a look at on how to solve this type of problem. So given the gradient function dy over dx equals to 2x plus 6 and y equals to 10 when x equals to 2, express y in terms of x. Means that we want to find y as a curve y given that the gradient function dy over dx equals to 2x plus 6 and there's a coordinate that lies on the curve with coordinate 2, 10. So means that this coordinate when x equals to 2, y equals to 10 sits on the curve. Okay, to find y, we need to integrate dy over dx with respect to x. So which means that we need to integrate the function 2x plus 6 with respect to x. Do the normal integration process. We will get 2x to the power of 1 plus 1 over 1 plus 1 plus with 6x plus with c. That is y. Simplify everything, we will get 2x to the power of 2 over 2 plus 6x plus c. Therefore, we will get x squared plus 6x plus c for equation y. Next, we find the value of c. It is stated that point 210 sits on the curve. Therefore, when x equals to 2, y equals to 10. Just insert into the equation that we found just now. So when y equals to 10, x equals to 2, so we just substitute the value. So 10 equals to 4 plus 6 times 2, 12 plus c, which means that 10 equals to 16 plus c. C equals to 10 minus 16, which is just equals to negative 6. Therefore, we have c equals to negative 6. Hence, final answer, the equation of the curve express y in terms of x, y is just equals to, from here, x squared plus 6x minus 6. That is your final answer. For this example, find the equation of the curve that has the gradient of 3x minus 1 to the power 4 and passes through point 1, 1. Means that we have a curve. It could be anything. And the gradient function of this curve is equals to 3x minus 1 to the power of 4. And there's a point that sits on the curve with coordinate 1, 1. So which means that when x equals to 1, y equals to 1. Again, to find gradient function, to find the equation of the curve, we need to integrate the gradient function with respect to x. So which means that we need to integrate 3x minus 1 to the power of 4 with respect to x. Here, we need to use integration by substitution, because if we do not want to use integration by substitution, we will need to first expand this formula, this equation, then only we can integrate. But the thing is, expansion can be very tedious because this is involving to the power of 4. So what we do, instead of expand and integrate, we use substitution method. So how do we do that? We let u equals to 3x minus 1. Therefore, du over dx equals to 3. du equals to 3 dx. Hence, the x is equals to du over 3, which means that dx is equals to 1 over 3 du. Once we find our dx, we substitute into this equation. So we will have y equals to integration of, substitute that, u to the power of 4, dx becomes 1 over 3 du, so times with 1 over 3 du. And we know that constant we can bring outside, so it becomes 1 over 3 times with integration of u to the power of 4 du, which is just equals to 1 over 3 u to the power of 4 plus 1 over 4 plus 1 plus c. So equals to 1 over 3 multiply with u to the power of 5 over 5 plus c. So let me shrink this a bit just to get some space down there. Okay. Equals to u to the power of 5 over 15 plus with c. So now we have y equals to u to the power of 5. Oh, I forgot. We need to substitute by u to the power of 5. U is just equals to 3x minus 1. Therefore, becomes 3x minus 1 e to the power of 5 over 15 plus with c. Okay. So now we have y equals to 3x minus 1 to the power of 5 over 15 plus c. The next thing we need to do, we need to find the value of c by substituting the point that lies on this curve. When x equals to 1, y equals to 1. Just substitute this value into the equation. So when x equals to 1, which means that 3 times 1 minus 1 to the power of 5 over 15, where y equals to 1, so plus a c. So we have 1 equals to 2 to the power of 5 over 15 plus c. C equals to 1 minus 2 to the power of 5 over 15. C equals to, let me see, negative 17 over 15. That is by calculator. Therefore, the final answer, since we already have the value of C, final answer, equation of the curve y is just equals to 3x minus 1 to the power of 5 over 15 minus with 17 over 5. 17 over 15. Alright. A curve with gradient function dy over dx equals to negative 3x minus 6 has a maximum value of 4. What does it mean by maximum value? Suppose that the curve maybe is a quadratic, we don't know. It should be a quadratic. So has the maximum value of 4. Means that the y value here is equals to 4. So if y equals to 4, what is the value of x? How do you know? Maximum value always refers to the y coordinate, not the x coordinate. So it means that it refers to the y value, not the x value. So when we talk about maximum value, so we know that this is 4. We need to find the corresponding value of x. Okay, how to find that? Given that the gradient function is dy, gradient function dy over dx equals to negative 3x minus 6. At maximum or minimum, dy over dx is equals to 0. Therefore, 0 is just equals to negative 3x minus 6. 6 equals to negative 3x. So, x equals to negative 6 but divided by negative 3. So, x equals to negative 2. So, the corresponding value of the maximum x value for the maximum point is negative 2. So, we have this coordinate, negative 2, 4. But the question wants us to find the equation of the curve. So we need to find y. We know that y is just integration of dy over dx with respect to x, which is just equals to integration of negative 3x minus 6 with respect to x. So equals to negative 3x power of 2 over 2 minus with 6x plus with c. Now we have this coordinate. Substitute into that equation so that we could find c. So if y equals to 4, then x equals to negative 2 minus with 6 times negative 2 plus with c. Just do the algebra. We will get the value of c equals to negative 2. Okay, therefore the final answer, the equation of the curve is just y equals to negative 3x to the power of 2 over 2 minus 6x plus with c, which is minus 2. That is your final answer, which is the equation of the curve. So this is the end of the second part of our integration video. For the next part, I will talk about definite integrals. So I hope you understand today's lesson. I'll see you soon. Bye-bye.